Hey everyone, welcome to another installment from Pro Engineering. Again, I have to apologize about the current setup here based on the fact that I'm not in the studio right now, but soon enough we'll be back. What this episode is going to focus on is the Tamiya Hornet EVO and a few of its unique characteristics. The first one is going to be the front suspension. Now, yes, I do have this lovely cage here. We will talk about that later on. But the first thing I wanted to mention was the front wheel track. So you can see here on the original side, this is about 20 millimeters per side wider than the standard Tamiya Hornet. I've got some photos up right now. I did compare this when I was at the house. Yes, the wider front track will increase off-road stability. The fact of the matter is it looks horrible. To me anyway. I've heard some people say it looks better. That's okay, not everybody's right. Fact of the matter is, I can't deal with the fact that the front wheel sticks out that much more than the rear wheel. It's bad enough that you've got this entire boil at the back of the car, but I can't handle the front. The thing is, the front steering on this vehicle is just masterful. For those of you that don't know, I covered this in my previous video, there's an entire 4-bar link and bell crank system in here, which works beautifully. It is, I mean, it's what I did for Superfly, but they just stuck it in a better area because they, didn't do what I did, which was left the front suspension pickups alone. They recreated it, and in my opinion, did a great job of it. It's just this track. Okay, so over here, we have a replacement front A-arm. So this A-arm is significantly shorter than the standard A-arm. It is still wider than the factory Hornet. But when this is installed, you will see that it gives the car back its original, just perfect stance that the original Hornet should have always had. Now, to do this, I've tried to simplify things. This car does come with some really good turnbuckles for the upper links as well as the front steering, and I wanted to reuse it. So this is what's going to happen. The upper link, which is a 32 millimeter turnbuckle, is going to move down to the steering arm. Now the steering arm, which I've taken apart already, was a 42 millimeter turnbuckle. We're not going to use that, but we are going to buy this here 22 millimeter turnbuckle. Now again, you don't have to do this. I just wanted to maintain all the turnbuckles because I thought it was very clean. To set this into your car, you're roughly going to make the gap between this ball cup and this ball cup. I've got it at about 23.75. It's pretty close to that. It might need a little bit adjusting on your car. So this will go from the steering ball stud right there, all the way to, all the way to that right there. You can see now that we're gonna have the front tires pretty straight. Next, the top. Using the same ball cups that I removed from the original setup, I'm gonna go ahead and thread them onto the 22 millimeter upper link. For the upper link, the gap I have between this ball cup and this ball cup is 8 millimeters. This all goes out the window if you're using any kind of aftermarket stuff, so just heads up there. So this will just pop in here. Okay. And there we have it. To change the arm, you'll use all the exact same hardware, but speaking of the arm, let's go ahead and take a look at it. I've altered quite a bit about the geometry, and part of this is to kind of maintain the cosmetics of the original design intent. But another part of it was, a little fuzz there from the cleaning here, was also the structural integrity of these parts. My recommendation to you is that you print them. This is the plate like that. The reason for that is the printer cross-section at this point makes it so that you're not going to have any kind of splitting when you use the screw pin in any of these holes. Secondly, it maintains that the layers are all just about like this to help with the structural integrity of the arms. The arm would be stronger in this orientation, but the problem now is you're going to have a weaker joint. So I suppose both will work, and if you have perhaps replace it with a full roll pin, that would do the trick. My recommendation again is to print it just like this. So we're going to remove the lower mount here. And like I said, these will go on exact same hardware, same location. My recommendation is that once you drill these, all 3 of these holes out when you're done. the 3D printer will not maintain the necessary tolerance to get the screws in there. The hole right now is 3.15 millimeters in diameter, but when it prints, it's closer to 3. So I recommend that you drill those out with either a 3.1 millimeter drill bit or a 1/8 inch drill bit. I would now back these 2 screws out and this third one over here just to get a little bit more clearance between the bulkhead and the steering rack, and then you'll be able to get these in. Okay, we're gonna pull this up just a bit. You also wanna make sure that you clean off any support material in here. You want these to, smoothly swing in their pivot points. If they don't, they're gonna bind up, and that's not gonna help anybody. Okay, there we go. And we'll take our longest pin, slide it right on. Come on, buddy. You can do it. I know you want to do it. There you go. So I'll slide it right on in there. I'll give you a little bit of insight over here. When you get the screw seated all the way down, my recommendation is you back it out and turn it in, I don't know, about 10 or so times. This is not a 3D printing thing. This is a plastic kind of thing. What's happening when I'm doing that is that the threads are further slicing into the plastic. This means that it not only makes the threads bite better, but it also relieves the stress in here. Anybody who knows of a lot of these harder Tamiya plastics, over time, they'll simply split open. That's one way to help mitigate that, is by effectively forcing the threads to dig into the arms deeper to relieve that stress. Okay, so we're gonna go put this in here. My light just died because of course it did. Okay, this is the middle length one. I'm not changing any settings on the shock. However, this reminds me, I am actually going to take out this little spacer that it came with to prevent overcompression. I really don't know the purpose of it, so we're just going to pull it because I did on the other side already. So if you follow the build instructions, this one right here, why they put it on the outside, we will never know. Okay, all the way in and then just back out. Okay, cool. Last one, you'll put that same shorter screw pin right here. Okay, and you're done. That is it. Front suspension is installed. I ended up bringing the top ones in to 7 millimeters, and that was a little bit better. There was a little bit too much positive, well, I shouldn't say positive camber. They were too vertical. With this way here, there's about a degree and a half of negative camber, which is about where you want it. So yeah, there you go. Here's the deal. If you're looking for increased performance, this is actually not going to do it. A wider wheel track, like I said before, improves off-road stability. But the fact of the matter is, I can't look at the car. I can't do it. I don't like the overall appearance with this wider front wheel track, and that's why I've done this. So the next thing we're going to talk about in the next video is going to be this cage. So stay tuned, and we'll cover the remaining bits for this car. We are not done at the cage. I do have some additional plans as well. Thank you, my friends. Pop this body on, and we'll see you next time.